Okay, today we are going to look at another type of factoring. So just side note here, so things that we've looked at factoring. Well, you should always check for a greatest common factor first, see if there's a GCF that you can divide out of everything. So no matter how many terms it has, that's what we should always kind of check for first. And then we talked about how if there's four terms, that's when we can usually do grouping. If we've got three terms, we basically turn it into four terms using, that ACB chart. Now today we're going to look at if there's just two terms, and that is called something we're going to look for what's called the difference of squares. Okay, and then that's pretty much going to wrap up the factoring section. Then we'll just do like kind of a combination, factoring using any and all of the above. And then, so this is just factoring, then we'll move into solving, where you still just factor and then you set everything equal to 0 to solve. So this pretty much wraps up the factoring section. Okay, so again, there's just two terms here, so it's obviously not going to be grouping, it's not going to be ACB chart. We should check for GCF, which there isn't anything that goes into both 1x squared and negative 16, so there's no GCF on this one. Okay, so there's two terms. So it's this thing called difference of squares. Notice how this is a perfect square and this is a perfect square. Now you could you could turn this into three terms and use the ACB chart. We're not going to do that every time. We're just going to do it kind of this time, or maybe a couple times so you can see the pattern. Okay, so A, remember that's like our leading coefficient. Well, if there's no number, it's an implied 1. C is our constant, in this case, negative 16. That negative goes with the 16, not the x squared. So negative 16. So basically, two things that multiply to negative 16. So, it could be like 1, 16, 2, 8, 4, 4. One of them is going to have to be negative. What's B? Well, there is no middle term. There is no B. So, it would be like 0x or 0. Well, if we put a negative attached to one of these, which one of these would add up to 0? Well, it would be the negative 4 and 4. So, you could rewrite this as x squared, and then instead of basically 0x minus 16, we could split that 0x into a negative 4x and positive 4x. So x squared plus 4x, or negative 4x, either way. It'll work either way. Whether you put the negative first or the positive first, it should work either way. All right, then we can do our grouping thing. The only thing we can take out of both of these is an x, which would leave us x plus 4. The only thing we can take out of both of these is, I would take out a negative 4 so that we have a positive x. We want these to match. So if you take out a negative 4, that would leave us a positive x and a positive 4. Negative 16 divided by negative 4 is positive 4. So we have our match. So we've got our x plus 4, x minus 4. Okay. We could always check that, and actually checking it might give you a little insight as to the shortcut here. So if you've got x plus 4 times x minus 4, and you do the FOIL, or the distributing, so I'm going to take x times both. So that's like the first outside, and then we'll do the 4 times both, the inside, and the last terms. So that's x squared minus 4x plus 4x and negative 16. Well, so if this is our first, outer, inner, last, or just think of it as distributing. The O and the I, oi, they're going to disappear. Oi, they disappeared. So I have x squared minus 16. So if you have basically the same terms, but you just change the sign on one of them, this positive 4x and this negative 4x are just going to cancel each other out. And then, of course, x times x is itself squared. 4 times 4, look, you're just taking 4 times itself squared. And because this sign was negative, you have a positive and a negative. Positive times a negative is a negative. So this is going to happen and create what's called a difference of squares, a difference of perfect squares. X is a perfect square, 16 is a perfect square of 4. You just basically squared your x, squared your 4. So hopefully between these two things, maybe you're starting to get like an idea that there is a shortcut, that if you've got two perfect squares, you don't have to, do the 0x, ACB chart grouping, all this and that. It's basically just going to wind up being the square root of each, and then you're going to have one of each sign. Because if you have one of each sign and the same number squared, those middle terms are just going to cancel each other out. So let's say I have x squared minus 100. Okay, so again, notice this is two terms. There is no GCF. They are the difference. We are subtracting, difference and subtracting of perfect squares. What's the number that's being squared to get x squared? Well, that's just x. What's the number being squared to get 100? That would be 10. And then you just got to make sure, again, you want one positive and one negative, so like the middle terms cancel out and you're left with the negative on the end. So you need one that's positive and one that's negative. So that's your shortcut. You basically just take the square root of each, because this is basically just, x squared minus 10 squared. So again, difference of perfect squares. And then you just take those and make sure you have one of each side. And then we can double check this. So if we FOIL this, x squared, first outside negative 10x, inside positive 10x, last negative 100. Oi, those two middle terms canceled each other out. So x squared minus 100. So yes, that works. Oh, we'll do one more. Let's say it's x squared minus 49. So again, these are perfect squares. Difference of perfect squares. Well, you just have to take, what squared would be x squared? Well, x times x would be x squared. And then what times what would be 49? Well, 7 times 7 is 49. But then you got to make sure you have one positive and one negative so that those middle terms, the OI, would cancel each other out, so that this positive 7x and this negative 7x would cancel each other out. And then this 7 times negative 7 is negative 49. Now, they're not all going to be that easy. Most of them are really and truly that easy, but they of course can get more complicated. Let's say we have 36x squared minus 121 y squared. Okay, so this is a little fancier. So this looks quite a bit harder than this, but if you look at them closely, these are both just perfect squares again. If you take 6x squared, 6x times 6x, that's 36x squared, minus if you take 11y, the quantity squared, 11 times 11 is 121, y times y is y squared. So these are still just the difference of perfect squares. So I'm going to put, the 6x, there's my 6x times 6x, that'd be 36x squared. And then my 11y times 11y, if I'm doing like my first and my last, 11y times 11y is negative, or is 121y squared, but I want it to be negative. So I need one positive, one negative. And then, again, that first would give me the 36x squared. The last terms would give me my negative 121y squared. And then my my inside terms are going to cancel each other out. The negative 66xy, positive 66xy would cancel each other out. So this is my factored form: 6x plus 11y, 6x minus 11y. So again, these are both still just perfect squares. So difference of perfect squares, you just basically take the square root of each one of them. Make sure you have a positive and a negative, so that the OI, that outside and inside terms, will cancel each other out if you were to FOIL to check. All right, let's do one one where you have to go a step farther. Okay, so I wrote down 18x squared minus 50y squared. All right, you may be thinking to yourself, well, 18 is not a perfect square and 50 is not a perfect square, so I feel stuck. I don't know what to do here. Well, keep in mind that again, for all the factoring, whether it's 4 terms, 3 terms, or 2 terms, we're supposed to look for a GCF first, is what we're supposed to do. A lot of the time we get so like into just jumping into, you know, our strategy, either our grouping, ACB chart, or difference of squares, that sometimes we forget that, oh, we're supposed to check for a GCF first no matter what. So there is a GCF that goes into both 18x squared and 50y squared. They're both even, right? So for sure you could divide both of these by 2. So that would leave me 9x squared minus 25y squared. Aha, now this looks like a perfect square. So I'm going to leave this 2 just kind of hanging out there. And then, okay, so what is this? What times what would be 9x squared? Well, that would be 3x. And then what times what would be 25y squared? Well, that would be 5y. But again, we want it to be negative 25y, so we need a positive and a negative, plus that positive and negative will make those outside and inside terms cancel each other out so that there's no middle term here. So this would be what that one would look like, all factored. Okay, I think that's it. So again, when there's just 2 terms, I mean, you could turn it into 3 terms by putting like a 0x or whatever, and doing ACP chart, but that's a lot of work when there's this nice little shortcut, this nice little difference of squares shortcut where you just basically say to yourself, okay, so what times what is the first term, what times what is the second term, and then make sure you have one of each sign, and you're done. So that's a nice, I mean, doesn't this look a whole lot easier than doing all of this? So there's a nice little shortcut for difference of perfect squares. Now, of course, the rub is that they have to be subtracted, and they have to be both perfect squares. Otherwise, the difference of squares shortcut doesn't work. But okay, and then yeah, watch out for they might throw in where there's a coefficient on both, variables on both. I don't think it's that hard. And then, if you come to one that you're like, wait a minute, these aren't perfect squares, I don't know what to do, remind yourself that, oh yeah, there might be a GCF that I'm supposed to divide out of both of these first, and then don't forget to put that GCF, in your final answer. That's another thing. Sometimes we're like, oh, I could divide them both by 2, but then, some people might get excited and see the difference of squares here, and then forget to put that you also factored out a 2. So don't forget your GCF in your final answer. So this is about as tricky as it'll get for today. All right, there is a multi-level pixel art. So there's just one pixel art, but it's multi-level. So you've got the mild through extra spicy, but it's just the one pixel art today. But all 4 levels.